Today we will be talking about minerals, and the most important thing about minerals is to know their physical properties. So what is mineral at the beginning? Mineral, when you need to define the mineral, you need to know that those four criteria, if they apply, so this will be a mineral. First thing is naturally occurring substance. Inorganic substance. It has an orderly internal structure and it has a fixed chemical composition. If you have all these conditions, then you have a mineral. Okay. So those physical properties we will study here are color, luster, streak, hardness, cleavage, and fracture. Also, we will know some stuff about crystal form and reaction with acids, magnetism, and specific gravity as an additional physical properties of minerals. Okay, all these are additional. You can add to them taste, odor, and feel. Let's start with luster. What's luster? Luster is the appearance of mineral when light is reflected from the surface of a specific mineral, and it is shiny or dull. Okay, you can see those figures, and you see some of them are glassy, some of them are shiny, and some of them are So minerals with metallic luster look like a metal, such as steel or copper. They are both shiny and opaque, even when looking at thin edge. Many metallic minerals become dull or earthy when they are exposed to elements for a long time, like silver. And then you have to bring them back to their shiny state when you wash them or add some chemicals to them. But for some elements like gold, they don't get rusty. Therefore, you must look at recently broken part of the mineral to see the real property of luster of this mineral. So minerals with an earthy luster look like earth or dirt. They are just dull. They don't have any shiny shapes, as you can see from those figures on the right. Also, you have one more type of the luster called vitreous. It's like glass, shiny and translucent or transparent. Minerals with waxy luster. This is another type of luster, like a wax. Look like a paraffin, typically translucent but dull. Also, you have one more type called pearly. It's like pearl. They have an appearance similar to pearl, translucent and shiny. When it comes to color, color is one of the most obvious properties of mineral, but it is often of limited diagnostic value because sometimes one mineral has many colors, like quartz, as we will see. Quartz, for example, can vary from colorless to white, yellow, gray, pink, and purple. So colors of some minerals such as biotite, black, and olivine, like olive, can be distinctive by its color. But for quartz, this is not the case. Okay, never use color as a final diagnostic property because, as we mentioned, that some minerals, one mineral can have more than you can see this from this figure. See, the quartz has many colors for the same mineral. See, it ranges from white, colorless, pink, purple, and so on. Streak. What is the streak? Streak is the color of the powder of the mineral, not the color of the mineral itself. So streak refers to the color of the mineral in its powder form, and may or may not be the same color of the mineral. And this property is helpful for identifying minerals with metallic or earthy luster. Okay. Because the streak plate is harder than most minerals, rubbing the mineral across the plate will give you the powder of that mineral, and we call it streak. This figure shows very clearly that the color of the mineral is different from the streak. So streak of this dark gray mineral, hematite, obtained by rubbing it on the white streak plate, is giving us a reddish brown color. Hardness. We have in hardness, it's just a resistance of the mineral for scratching by other materials. And we have very famous scale called Mohs scale that gives you hardness scale, starting from talc, takes number 1, then you have gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and finally you get the highest or the hardest mineral is diamond. See, this is called Mohs hardness scale. It starts from 1 and ends by number 10. Here is a scale, as we mentioned: talc, gypsum, calcite, fluorite, apatite, feldspar, quartz, topaz, corundum, and diamond. This is the way we test mineral hardness. Harder mineral, quartz, scratch the softer one. Okay, the very famous two properties of minerals are cleavage and fracture. The way we need to know the difference between them, the way in which mineral break, either by cleavage, which is a very weak planes, and mineral could have one cleavage plane or 2 cleavage plane or more than that, and across those planes the mineral will break down. So this we call it cleavage if we press on those levels on those planes. So a mineral that exhibits cleavage consistently break or cleavage along parallel flat surfaces or planes called cleavage planes. Mineral fracture if it breaks along random. So fracture when the mineral breaks randomly, not along those cleavage planes. Here's some examples. This is on the left side. The biotite mineral has a basal cleavage, so which is one cleavage, one plane of cleavage. But here you can see the orthoclase on A and other mineral on B and hornblende. So you'll see the first one, cleavage in potassium feldspar, which we call it orthoclase, intersects at 19. So we have 2 cleavage planes, and you can have more than this. Here you can see different examples of different kinds of cleavage planes. You have basal, 1 cleavage, prismatic, 2 cleavage planes, and non-prismatic in cubic, and rhombohedral, octahedral, and dodecahedral. And please read the lecture notes to get to understand more of the physical properties of minerals. Thank you, and see you next lecture. Bye.